Over the past century, stadiums have grown from modest ballparks into colossal multi-use complexes that double as engineering marvels and cultural landmarks. But what's happening right now in the United States takes this legacy to a new level. Across the country, a series of record-shattering stadiums are under construction, projects that blend cutting-edge technology, futuristic design, and environmental resilience. By the end of the decade, these arenas will redefine how Americans experience sports and live entertainment. Let's take a tour through the largest and most ambitious stadiums rising across the nation in 2025, exploring how each pushes the boundaries of architecture and engineering. Number 8. Nissan Stadium. When the new Nissan Stadium opens its doors in 2027, Nashville will not only gain a world-class sports arena, but also an architectural landmark unlike any other in the NFL. Most traditional stadiums are designed around concentric rings, symmetrical and circular, with seating bowls stacked in predictable layers. The new Nissan Stadium, however, breaks away from this convention entirely. Its sweeping asymmetrical form has been carefully designed to respond to the city's geography, particularly its location along the east bank of the Cumberland River. This irregular footprint is not merely an aesthetic choice, but a functional necessity. The stadium had to integrate seamlessly with existing city infrastructure, including roads, bridges, and floodplain zones. This meant that before vertical construction could even begin, site crews undertook a rigorous ground improvement program. The soil beneath the site was stabilized using dynamic compaction, surcharge loading, and the installation of wick drains, which accelerated settlement and ensured that the foundation would remain stable under the stadium's immense weight. The structural backbone of the stadium rests on deep drilled shafts that extend down into bedrock. These shafts support grade beams and pile caps, which distribute vertical loads across the structure. Unlike stadiums that rely on uniform column layouts, Nissan Stadium employs staggered grids and variable bay widths to accommodate its many functions, including open concourses, press decks, and premium club levels. Construction has required extreme precision, with tower cranes hoisting formwork, reinforcing steel, and prefabricated assemblies into position. Perhaps the most striking feature will be the roof. Covering over 2/3 of the seating bowl, it is constructed using a combination of structural steel, cable tension systems, and lightweight ETFE membrane panels. Some of the cantilevered trusses extend more than 200 feet over the stands, a feat of engineering that required temporary shoring towers and hydraulic strand jacks to position them with millimeter accuracy. The roof not only provides shelter from Nashville's unpredictable weather, but also creates an iconic profile visible across the skyline. Integrated into the canopy are concealed drainage systems that feed into underground retention tanks, part of a comprehensive stormwater management strategy. Inside, fans will experience a technological marvel. Electrical systems feature dual-feed switchgear to prevent power interruptions, while thousands of conduits embedded into the seating risers support seat-integrated power, lighting, and data ports. The concourses will be finished with terrazzo flooring and steel mesh railings, while suites and hospitality areas will feature modular walls and high-end finishes. By the time commissioning teams finish testing every system in 2027, Nissan Stadium will represent a new standard in stadium architecture, blending bold design with operational reliability. Number 7. Commander Stadium. If Nissan Stadium emphasizes integration with its site, Washington's new Commander Stadium focuses on redundancy, flexibility, and mechanical innovation. Scheduled for completion in 2028, it stands apart from most projects because of its sequencing. Instead of beginning with the foundations and steel skeleton, engineers prioritize the mechanical systems, building the stadium's operational heart before its bones. The mechanical strategy revolves around decentralization. Rather than relying on a central plant, the stadium uses distributed mechanical mezzanines at multiple elevations, each linked by vertical shafts running through the structural cores. These shafts carry chilled water piping, ventilation ducts, electrical buzzways, and fiber optic trunks, ensuring that every part of the stadium has efficient and redundant systems. This design was specifically developed to handle Washington's climate, where humid summers and cold winters create complex heating and cooling demands. Structurally, The foundation system is a hybrid of precast piles and drilled shafts, chosen to accommodate subsurface variability across the urban site. Before these could be installed, crews had to stabilize loose soils and historical fill through ground densification. Once the ground was secure, engineers began erecting the core walls through slip forming, a continuous process that allows reinforcement and embedded items to be placed as the walls rise. Seating elements are being prefabricated offsite and delivered just in time, each one containing pre-installed conduits and mounts for railings, lighting, and display systems. Visually, the Commander Stadium will be a striking addition to the Washington skyline. Its exterior combines aluminum panels, glass, and ventilated rain screens. A system of vertical louvers creates a shifting, dynamic facade that changes appearance depending on the viewing angle. Integrated LED lighting transforms the exterior into a massive programmable canvas capable of displaying team branding and event-specific visuals. Above the seating bowl, a lightweight cable-supported canopy shelters fans without fully enclosing the stadium. The roof's ETFE panels are coated to reflect solar radiation while allowing soft natural light into the stands. By 2028, this project will stand as one of the most mechanically advanced stadiums in the world, prioritizing operational redundancy and fan comfort. It is a venue designed not just to host games, but to function as a fortress of resilience and innovation. Number 6. Chicago Bears Stadium. For Chicago, the Bears' new stadium represents more than a new home for football. It is a civic statement, blending the city's historic architectural identity with a forward-looking approach to sports venue design. Scheduled to open in 2027, the facility emphasizes circulation and multi-tiered access, creating distinct vertical zones for general admission, club seating, and suites. The heart of the design lies in its circulation strategy. Vertical access is organized through dense cores of stairwells, escalators, and elevators, all aligned with structural walls that double as shear components, giving the building both functionality and stability. Fans will move seamlessly between levels, with premium areas separated from general access zones, a design that enhances both crowd flow and safety. At the field level, Chicago's extreme climate posed unique challenges. The playing surface will be built on a layered, engineered base that includes a compacted subgrade, subsurface drainage pipes arranged in a herringbone pattern, and heating coils embedded in a concrete slab. This ensures that the field remains playable even during harsh Midwest winters. Above this lies engineered sand and a natural grass root zone, supported by trench drains and access vaults for utilities. The seating bowl combines precast components with a cast-in-place frame, while the upper tiers are supported by steel raker beams and deep caissons drilled to bedrock, designed to resist frost heave and soil variability. One of the most innovative features of the project is its canopy system. Instead of being installed last, as in most stadiums, the canopy is integrated early into the structure because it doubles as part of the lateral stability system. Long-span steel trusses form the canopy, which is clad with polycarbonate panels embedded with solar cells to offset energy consumption. Externally, the stadium is designed to echo both Chicago's historic civic buildings and its modern skyline. Glass curtain walls combine with steel cladding and stone masonry to create a civic landmark that feels rooted in the city's identity. Surrounding the facility, a pedestrian plaza with integrated snowmelt tubing ensures year-round accessibility. When the Bears take the field in 2027, fans will not only see a state-of-the-art football stadium, but also a structure that reflects the spirit of Chicago itself. Number 5. EverBank Stadium. In Jacksonville, the new EverBank Stadium is designed with one primary force in mind: nature. With its location along the St. Johns River and vulnerability to hurricanes, the design team placed resilience at the heart of the project. Scheduled for completion in 2028, it will be a facility capable of withstanding Florida's storms while offering a modern fan experience. The foundations employ a pile-supported mat system, combining steel 8 piles with cast-in-place caps. Before installation, crews used surcharge loading and wig drains to consolidate soft coastal soils, ensuring the stability of the wide foundation footprint. Once complete, This system distributes both dead and live loads while minimizing settlement. The stadium's seating bowl relies heavily on precast modules that can be lifted into place by tower cranes. The upper decks will cantilever dramatically, extending over lower levels without obstructing views. Structurally, this is achieved through long-span trusses supported by massive perimeter columns. The roof canopy is a lightweight structure constructed from curved steel girders and PTFE fabric panels. Designed to withstand hurricane-level winds, it shelters fans from intense sun and rain while maintaining an open-air atmosphere. Integrated gutter systems and underground retention tanks capture rainfall, reducing flooding risks during tropical storms. Inside, mechanical and electrical systems are divided into north and south zones, each with its own plant rooms, chillers, air handlers, and backup generators. Redundant fiber optic networks ensure uninterrupted digital connectivity, while smart sensors embedded in the Bermuda grass field monitor moisture and temperature, feeding data into automated irrigation and heating systems. By the time it opens for the 2028 NFL season, EverBank Stadium will not only replace its predecessor, but also set a benchmark for storm-ready sports infrastructure. Number 4. Highmark Stadium. Buffalo's upcoming Highmark Stadium embraces the realities of Western New York's winters. Anticipated to open in 2026, the project is engineered from top to bottom for cold weather performance. Site preparation involved excavation down to undisturbed subgrade, followed by compacted backfill to counter freeze-thaw cycles. The foundations rely on drilled shafts and reinforced grade beams, with below-grade waterproofing and under-drain systems installed early to protect against groundwater intrusion. The stadium's cores were the first vertical structures to rise, serving as circulation routes while housing MEP infrastructure and stairwells. Around them, modular steel assemblies form the frame, supporting two major seating tiers and premium areas designed for clear sightlines. The roof canopy, covering 2/3 of spectator seating, is built from truss girders anchored into reinforced caissons. Its PTFE membrane allows snow to slide off naturally, while heated gutters and stormwater tanks manage meltwater. Mechanical systems are distributed into two zones, one for fan-facing amenities such as concessions and suites, and the other for field operations, security, and logistics. Energy efficiency is achieved through economizers, occupancy sensors, and energy recovery ventilation. Emergency backup is provided by diesel generators in hardened enclosures, ensuring uninterrupted operation during blizzards. The playing surface features a heated slab with embedded tubing that keeps the root zone warm even in sub-zero temperatures. This hybrid grass system ensures high performance, while underground access tunnels allow maintenance and broadcast crews to operate without disrupting spectators. When complete, Highmark Stadium will stand as one of the most cold weather resilient stadiums ever built, a true fortress against Buffalo's winters. Number 3. Las Vegas Stadium. In Las Vegas, construction is underway on what may become the most technically advanced indoor stadium in the world. Anticipated to open in 2030, this project faces unique challenges due to its urban location and desert environment. Because of the site's position in a dense urban grid, extensive underground mapping and seismic studies had to precede construction. Soil cement stabilization and moisture barriers were installed to combat differential settlement in arid soils. The foundation employs a post-tension concrete mat embedded with seismic base isolators, allowing the structure to decouple from ground motion during earthquakes. Vertical construction begins with concrete cores housing stairwells, elevators, and mechanical risers. Around them, a steel skeleton rises in tiers, with long-span trusses hoisted into place by crawler cranes. The stadium's crowning feature is its fully enclosed roof, composed of steel arches and transparent ETFE panels. Supported by super trusses anchored into massive buttresses, the roof is engineered to withstand both desert heat and seismic risk. The roof will also integrate photovoltaic panels and dynamic shading fins that adjust to solar intensity. Inside, a retractable grass field tray will roll out of the building to receive natural sunlight, preserving turf quality. The tray glides on steel rails and hydraulic actuators guided by laser sensors, a system that allows multi-purpose flexibility without sacrificing natural playing conditions. Energy demands will be met by massive chilled water plants running on closed-loop systems with thermal storage tanks. Air distribution will use under-seat displacement vents and high-induction diffusers, while electrical rooms will house redundant transformers and emergency systems. By 2030, the Las Vegas Stadium will redefine indoor sports and entertainment in the desert, a technological masterpiece as dazzling as the Strip itself. Number 2. Inter Miami Freedom Park. In Miami, the Inter Miami Freedom Park Stadium is on track for completion in 2025, making it the first of this new wave of stadiums to open. Built on a former municipal golf course with contamination concerns, the site required significant environmental remediation. Soil excavation, chemical stabilization, and vapor mitigation membranes were installed to protect future occupants. Groundwater monitoring wells were deployed to track subsurface conditions throughout construction. Drainage posed another challenge, given Miami's flat topography and heavy rainfall. Engineers developed bioswales and retention tanks beneath parking areas to capture stormwater. Pumping stations tied directly into the city's infrastructure, ensuring resilience during intense rain events. Structurally, the stadium rests on a matte foundation supported by driven piles. Its frame is a composite of concrete cores and steel trusses, forming the skeleton for the seating bowl and canopy. The single-tier bowl has a steep pitch, designed to create an intimate match-day atmosphere. Precast risers and steps were prefabricated off-site, each embedded with conduits for lighting and wireless access points. Above the stands, a sweeping PTFE canopy shelters spectators while also capturing rainwater for reuse and irrigation. The design emphasizes sustainability and efficiency while still delivering a dramatic architectural statement. Freedom Park will be a jewel for Major League Soccer, embodying Miami's identity with a modern, fan-first venue. The project itself is far more than just a stadium. Inter Miami Freedom Park is part of a larger 131-acre redevelopment that includes a public park, hotels, restaurants, office spaces, and recreational areas, making it one of the largest privately funded developments in South Florida's history. The stadium is planned to seat around 25,000 fans, keeping it tailored to soccer-specific design rather than sprawling NFL-style mega venues. Unlike traditional stadiums that prioritize vertical expansion, the intimate bowl ensures every fan feels close to the action, echoing the intense atmospheres found in European football grounds. Sustainability has also been central to its mission. Rainwater captured from the canopy will be recycled for landscaping and cooling, and renewable energy systems are expected to offset a portion of operational costs. The inclusion of shaded pedestrian walkways, bike paths, and direct links to public transit reflects Miami's push towards sustainable mobility. Additionally, developers pledge that 58 acres of the property will remain open green space, accessible to the public year-round. With Lionel Messi's global profile elevating Inter Miami's visibility, the stadium has been designed with international tourism in mind, including world-class VIP facilities and broadcast-ready infrastructure. By integrating the stadium into a mixed-use urban district, Freedom Park is positioned not only as a home for soccer, but as a permanent economic and cultural driver for Miami. Number 1. EverBank Stadium. Unlike the towering mega stadiums rising elsewhere, EverBank Stadium, planned for completion in 2026, takes a different approach. Its design emphasizes horizontal integration and community connectivity, creating a low-profile venue that blends into its surroundings. The site features landscaped entry plazas, pedestrian bridges, and ADA-compliant walkways, making it one of the most accessible stadiums in the country. Foundations rely on precast piles driven into glacial till, topped with reinforced slabs forming the seating bowl and service levels. The superstructure uses a hybrid of steel framing and concrete cores. Vertical circulation shafts and mechanical risers were prioritized early, anchoring both the building's stability and functionality. Inside, the seating configuration includes two primary tiers with an intermediate mezzanine reserved for suites and clubs. By partially recessing the lower bowl into the ground, designers created a sense of intimacy while maintaining capacity. EverBank Stadium is a reminder that not every stadium must dominate the skyline to be transformative. Its focus on ground-level integration and accessibility ensures it will serve not only as a sports venue, but also as a community gathering place. Although designed with modest proportions compared to an NFL or MLB facilities, EverBank Stadium is expected to hold approximately 30,000 spectators, making it ideal for soccer, lacrosse, concerts, and community events. The horizontally oriented design ensures that pedestrian circulation feels natural and open, avoiding the bottlenecks often seen in stacked vertical stadiums. Plazas around the stadium will feature public art installations, performance stages, and year-round programming to ensure the site remains active beyond game days. Accessibility is a major priority, with more than 2,000 accessible seating options and a network of ramps, bridges, and shaded walkways designed for universal comfort. The architecture integrates local materials and landscaping, with tree-lined plazas that echo regional ecological patterns. Energy efficiency is also central. Designers are implementing LED lighting, low-flow plumbing fixtures, and a partial solar array to offset power demand. Stormwater will be captured and filtered through bioswales and rain gardens, reducing environmental impact. Beyond sports, the venue is expected to become a community hub, hosting graduations, high school championships, and cultural festivals. Its intimate design ensures fans are close to the field, while the inclusion of premium suites and club seating provides financial sustainability. By combining modest scale with advanced engineering and sustainability, EverBank Stadium represents a new model of community-first stadium development. And that wraps up our deep dive into the jaw-dropping stadiums currently under construction across America. If you enjoyed this video, don't forget to hit that like and make sure you subscribe to the channel. Thanks for watching, and we'll see you in the next one.